In this video, we'll talk about quadratic expressions and how to factor them. And this will be a lead into solving quadratic equations. So let's talk about a quadratic expression. In particular, we're talking about quadratic, meaning that there is an x squared term in the expression. So we've talked a little bit about the more simple ideas between factoring, and if they have two things in common, we're going to get to a little bit more advanced factoring today. So a quadratic expression would be like x squared plus 4x plus 3. And in particular, we're going to look at ones here where the leading coefficient is a 1. Now, it's not always going to be written there because x squared is 1x squared. We'll talk about what happens when this is not a 1 in another video. But for now, we're just going to look at the more simple version of a quadratic expression. So let's review how to multiply two binomials in particular. So regardless what method you like to use, you can use FOIL, or smiley guy as I like to call it, or we can do double distributive property. So you could take essentially x times x plus 2 plus 1 times x plus 2. Whatever method you choose, it should boil out to be x squared plus 3x plus 2 once you do all this simplification. Now what we are essentially going to do in this lesson is we're going to be given an expression like this green one here, and we're going to be asked to undo it, to rewrite it as this factored expression. And again, this will be a lead into solving equations, much like we did when we were talking about monomials and factoring them out. We're going to use that zero product rule here, and that'll be the next lesson. So when we're looking at these kind of expressions, there's a trick that you may notice. If I'm looking at the 1 and the 2, and just note that this only works if the leading coefficient on your terms, on both your x's, is a 1. So that's where this is a special case. And we'll talk about the more complicated cases later. But for now, we're going to look at the 1 and the 2. And if you'll notice this 2 times 1 makes the 2. And that makes sense because we're looking at this line right here, where I take the 1 times the 2. Or if you do the double distributive method, that's the only multiplication of the numbers there. 1 times the 2. And this 3 comes from an intermediate step where if I were to do double distributive or do the foiling, either way, we're going to have x squared plus 2x plus 1x plus 2. Notice that we're looking at, technically, this is a 2 plus 1 times x. We're going to add the 1 and the 2 to make that middle term. So this is 2 plus 1. Now how this works, and we'll talk about this in a couple examples, is you're going to look at those two individual numbers or not the 2, but you're going to look at this number at the end and think, okay, what are the factors of 2 that add to make the middle number? And that might be a little confusing with all this going on the screen right now, but we're going to break it down in a couple examples. So let's take a look at what this looks like in practice. Let's look at this example. Let's say I wanted to factor this x squared plus 5x plus 6. Now, we can't use our previous methods of factoring because if I'm looking at this, the first two chunks here do have an x. However, 6 doesn't have an x. The 6 has factors of 2 and 3 and 6 and 1, but I can't pull any of those out of these two. So we have to do this a different way. So here's what it's going to look like in practice. The first thing I'm going to look at is this 6. So we think about the factors of 6. So what two numbers multiply to make 6? Well, the first case is 6 and 1. Second case is 2 and 3. And that's all I can think of. Now I just have to ask myself, okay, looking at these signs, okay, I'm looking at factors of positive 6 that add to positive 5. Well, 6 and 1 could make 5, but I'd have to subtract the 1, which once I take 6 times a negative 1, that's going to make a negative 6. So this one is ruled out. Now if I look at the 2 and the 3, 2 times 3 does make 6. 2 plus 3 makes positive 5. I think that's the one. So essentially what we're going to write is we're going to make our expression. The only way I can get x squared is if I have an x times an x in my first slot. And then we're going to have a 2 and a 3, both of these being positive because of the signs here. We're thinking factors of positive 6 that add to positive, add to positive 5. And if you're unsure as to whether or not this is truly the factored form, which it is, you can always FOIL it out and see if you get the same thing. Now let's look at another example. So, what we're going to look at again, we're going to look at just the 9. We're going to think about, okay, what are the factors of 9? Well, there's 9 and 1, there's 3 and 3, and then I could also have 2 negatives of each. So I could have -3, -3, -9, -1, and we could have done that on the last one too. So just keep that in mind. You don't necessarily have to write down these negative cases, but they're always good to keep in mind because now I have to look at the -6. So I have to pick numbers from this list that I can make -6 with once I add them together. So I can rule out these positives because once I add 2 positives, it's going to be more positives. So it means it's got to be one of these bottom 2. -9 and -1, well, that makes -10. So I can rule that one out. -3 plus a -3, that makes -6, so I think that's the one. So, again, we're going to write it as x and x, and then we're going to have -3's, or we can write it as x minus 3, x minus 3. Now, as another shorthand, you could write this as x minus 3 in parentheses squared. Both of these would be totally acceptable. And it's the same kind of process. You're asking yourself, okay, what? I'm going to look again here first, and then I'm going to look at what numbers add to make this number second. So it's one of those things where the more you do it, the more it makes sense, and we're going to spend a lot of time with this.